Skills are learned because things don't always go right. Mishaps, mistakes, near misses, and full-on safety incidents prove to be valuable teachers. These lessons can create meaningful career paths.
Process Safety with Trish and Traci is a production of Chemical Processing. Chemical Processing focuses on serving engineers, designing, and operating plants in the chemical industry.
Welcome to this edition of Process Safety with Trish and Traci, the podcast that aims to share insights from current incidents to help avoid future events. I'm Traci Purdom, Senior Digital Editor with Chemical Processing, and as always, I'm joined by Trish Karen, the Director of the IChemE Safety Centre. Hey Trish, what's going on in your world?
Hey Traci, well, not a lot's changed over here at the moment. We're still just, we're now heading into winter in Melbourne in Australia, so it's getting a little bit cooler over here. Not icy or snowy, we don't get that cold, but just a little bit cooler. So just preparing to rug up with the winter coats down here at the moment.
And we're just the opposite. We're getting some nice warm weather. In fact, right before I hopped on the call with you, I was filling my hummingbird feeder, and they were all waiting for me. So they're busily eating the nectar that I just put out for them. So we're about to start the hot days of summer here.
Nice. Hummingbirds are quite a beautiful bird to look at. Amazing. From an aerodynamic perspective, they're amazing creatures.
It is. Every time I see, and I see them often, but every time I see them, it's like a little treat, and I freeze and watch and hope that they stay as long as they can. So it's good stuff. Yeah. Well, today we're going to get a little bit personal, at least in terms of how you landed in your current role. Obviously, you don't just apply for the job of Director of the IChemE Safety Centre. There has to be a path that led you there, and as with any practice, skills are learned because things don't always go right. Can you walk us through your career and things you've learned the hard way? I know you started out as a mechanical engineer designing and installing aviation fueling systems. So tell us, can you walk us through how you got to where you are today?
Sure. So it was a long and winding journey, I would say. I never really had a career plan of where I was going to go. And in fact, the reason I studied engineering was simply because it was a sort of degree that you could go and get a job from rather than have to go and do some other form of study or some other form of training to actually become a professional in an area. So that's why I did engineering in the first place. I got a job in an oil company. I started doing, as you said, design and construction of aviation fueling systems. And that was a really fun job. I loved working at airports. I loved working in the fueling system. Thinking back in hindsight, that was the first job I was in when I had my first process safety incident. And fortunately, no one was killed in the incident, and no one was seriously injured. There was a minor injury. In fact, it was actually to me, the minor injury in the end. And it was an interesting situation. I was building a fueling hydrant system, and we were at the stage where we were recommissioning the line. We were starting to refill the line with Jet A1 fuel, and so we were venting it out a high point in the line into a truck. And we'd vented out enough content. It was time to shut that system down because we'd repacked the line with jet fuel, and we went to shut the isolation ball valve on the hydrant system, and it wouldn't shut. We couldn't shut off from where the hose was connected to the truck, and no matter what we did, we just couldn't shut that valve. And so in my youth, I thought, well, there's a dry brake coupling connected to this too. Let's just disconnect the hose. That will shut, and at least we can disconnect the truck because we've still got jet fuel flowing into the truck, and the truck's about to overflow. And so we then disconnected, and the dry brake coupling didn't close either. So at that point, we actually had a jet fuel fountain happening, which is never a good thing.
No.
And so we then had to shut down the hydrant pumps. Basically, you've just got to let the line depressure. So you've got fuel coming out. There's nothing you can actually do at this point. And it turned out that the cause of the incident was when we had assembled the fittings for the vent point. We had a ball valve and we had a dry brake coupling. So a dry brake coupling has got a plate in it, and it's a spring-loaded, and it's got a spindle that goes down. And so the idea is that when you connect up, it opens up it puts force on the spring and the plate, and it opens up and fuel can flow around it. So when you disconnect, the plate spring's closed again. Now, that spindle went down into the next connection of the ball valve, because what we didn't realise at the time was there was actually a long and a short side on this ball valve. And if you installed the valve upside down, now in theory, a ball valve upside down shouldn't be a problem. It's a ball valve. What happened, though, when you open the ball valve and you open the dry brake coupling, the spindle went into the bore of the ball valve.
Oh.
So when it came time to close the ball valve, we couldn't close it because there was a spindle down through the bore. And we tried very hard to close it. We tried so hard to close it that we bent the spindle. That's why the dry brake didn't close. And so it was a design understanding issue. Now, neither I had picked it up nor the very qualified and experienced fitter who had assembled the assembly didn't pick it up either. It was only 5 or 10 mil difference in the short side and the long side. It wasn't significant, but it was enough. It was enough to be a problem for us. And so that was my first one. I mentioned the injury. I immediately got the operator, who was then doused in jet fuel, into water so he could actually take his jet fuel-soaked clothes off without creating any static issues, because there's a potential for static and ignition. So he was fine. I continued to stand there doing what I was doing, managing the situation, dealing with it all, and I had elastic-sided safety boots on. And I was standing in a sandy soil, and over the course of about an hour or so, the jet fuel soaked into my boots and through the elastic and onto my feet. And so I had some chemical burns on my feet for a couple of weeks. And that was the only injury that came out of it. But it taught me a lot about construction. It taught me a lot about managing a site. It taught me a lot about managing an incident. At the time, I didn't know it was a process safety incident. I reflected on it years later and thought, wow, that was my first process safety incident. And that was an interesting way to start my career, I guess. And then after a couple of years of designing and installing fuel systems, I decided I wanted something really different. So I went and worked in a refinery on shift, unloading crude oil tankers. So I went and did shipping operations. And shipping operations was something completely new. Working on shift was something completely new. I was supervising operators. It was just a whole different experience. It was probably actually one of the most fun jobs I've ever had in my life. But it was a very difficult job to do as well. There was a lot of hurry up and wait. You had to have everything ready at a certain time, and then you just had to wait for the next stage. And there was nothing you could do to prepare for the next stage ahead of time. You just had to hurry up when that arrived.
Right.
And so it was a challenging role in that space. And one day I had a ship turn up, and it turned up with its cargo at 60 degrees Celsius. It was a very high pour point crude, so it needed to be heated up. And our pipeline was rated at 55 degrees. And I made the wrong decision to unload the ship. And the pipeline was above ground, partly above ground, partly underground. And everywhere it came up from underground, it then had a really big concrete anchor. And in between the concrete anchor and the underground section, there was a flange. Every one of those flanges leaked because the pipeline expansion couldn't handle it. It was rated at 55 degrees, and 55 degrees was what it should have been, not 60. There was no leeway in that. And again, at the time, I didn't know that was a process safety incident. I learned that after the fact when I sat back and reflected and thought, wow, this was actually an interesting incident that occurred due to my lack of competence in what I was doing. Clearly made a wrong decision, and it was mine. It was my decision to own. I did it. And I owned it at the time, but it took me a while to actually reflect back on the organisational and the factual, the task-related issues, the human factors-related aspects of what I was doing, and actually realising I wasn't competent to be making that decision at that time. I never made that decision again. I never made that mistake again. I learned. I did learn my lesson in that one. And luckily, no one was injured, no ongoing environmental impact either, so that was a good thing as well. But they were sort of like they were my two, wow, so I've actually caused 2 process safety incidents in my life. Fortunately, no one's died in them. And then I was also working at a refinery the day the Longford explosion happened in Australia. And that was probably the major turning point for me. And I was in the refinery planner's office when the phone rang to say that there'd been an explosion at this facility and that they were having to shut down the crude oil pipeline that was running to us. And I looked after the pipeline operations at the refinery at the time, so it was, within my area to deal with this issue. And I remember the look on the face of the planner, and we immediately turned the radio on and listened to the news reports, and they announced that there were 2 people missing in this explosion. And the look on everybody's face as we all just turned around and looked at each other, because we knew at that point with what they were describing, these people weren't missing.
Ugh.
And working in a similar sort of facility, that really, really hit home at me. And I think it was the turning point that took me to the position to say, we can't do this. We can't have people dying like this at work. And that's what started me really in the safety journey. And then I ended up back in the aviation business again in a safety role, and discovered that I actually really loved working in safety. It's the first time I'd been in a safety role as such, a real safety role, and I loved it, absolutely loved it. And that's why I then pursued my career through that. So after about 10 years in the oil industry, I then left and went into chemical industry as a safety manager for a company and doing their safety case. So leading their PHAs, that sort of stuff, submitting their licensing requirements to the government. And then I ended up in a very unusual situation where I was selected by the Industry Association to represent them on the drafting of, first of all, or the redrafting of Victoria's major hazard industry laws, and then the drafting of Australia's major hazard industry laws as well. So I then started to do a lot of government committee work on drafting of legislation, how you write it, how you get it in a practical sense to actually achieve the safety outcome rather than it just being bureaucratic. So I was the industry representative in that space, as well as I also sat on a committee that provided oversight to the Victorian regulator, which was a finding from the Longford incident, that the regulator also needed a degree of oversight over them. And so for about 7 years, I sat as an industry representative on that oversight committee of the regulator as well. So I had the operations experience, the engineering experience, the safety manager experience, and then I started to work in this space while still working in industry of representing industry to government and working on committees and those sorts of things. And, I mean, these were all jobs that sort of it looks like an interesting thing to do at the time. I went into every job in my career. I didn't plan any of the jobs I went into in my career, but I went into them and sort of went, well, I've never done that job before. Let's see if I like it. And let's see if I'm any good at it. Turns out I'm actually quite good at operations management. Don't like it. Don't want to be in operations. I don't enjoy it. I'm actually very good at it. Don't enjoy it. Turns out I'm good at safety and I like it, which is a real win for everybody, I think. Makes me a lot happier when I'm enjoying my job. So I've sort of always went, well, I've never tried that. Let's give it a try. So when it came time for this job, by that stage I'd moved back into gas production and distribution businesses. So, I was looking after, from a safety perspective, I had a gas production plant. I had a lot of gas distribution facilities around the country, and this job came up, and it was really just almost a perfect fit. It was, I got to work in safety, but I got to try and improve safety, not just for one company, not just for the company I worked in, but for industry sectors at large. And so from that point of view, it's really satisfying. But it also, my government experience, my committee-related experience really helped bring these things together and understanding what it's like to be in a company when an industry-type association wants you to do something. I'm now the industry-type association wanting people in companies to do something. So that understanding, I'm acutely aware that an email from me to one of my member companies is not the most important thing in their day. So I really need to make sure that I don't overuse it, and when I do, it's really important for them because I know they've got other jobs to do. I'm a little sideline thing that they do as well. So that's sort of, in a roundabout way, how I stumbled into this role to set up the IChemE Safety Centre.
Well, I wanted to kind of dial back a little bit and kind of dig in a little bit on, you mentioned that at the time you didn't realize that some of these things were process safety incidents, and the human factor of that ball joint, not understanding that you know, the pin dropping down. Were there any procedures that you were to follow that would have told you to think of those things, or were there any incident investigations after those incidents?
So at the time, no, there were no clear procedures on how to assemble that particular joint assembly other than our typical standard drawing. And the long side, the short side issue, as I said, it was only about 5 or 10 mil. It was very easy to install it incorrectly and not visually notice it because it was that similar a distance. So you looked at it and it looked like the drawing. If you had got a tape measure out and measured it, you would have discovered it was 5 or 10 mil out on the drawing. But the levels were all okay. So keep in mind, we were installing pipelines that go underground, but they have to actually rise up to a very specific pavement height. So you do a lot of work on getting your levels right. All your level calculations are within a millimetre or so of each other on installation from drawing. The levels were fine. It's just one piece was upside down. So no, there were no procedures in it. We did do an investigation, which is how we discovered that it was installed the wrong way and we had this issue and that's what caused the bending of the spindle and those sorts of things. So we did have the investigation process that we went through and obviously the reporting process. There was environmental impact there. But, I mean, at the end of the day, we were designing pipeline systems to a set of standards. But the standards were always focused on maintaining the jet fuel quality, making sure the system was clean, and making sure you had your overall level height correct, because that was what was important for continuity of the pavement surface that the planes drive on and ability to connect up with the hydrant carts to fuel the planes.
Now, would Trish today in that role do anything different?
Yeah, Trish today would measure every single assembly and make sure it was put together the right way. But that's something you learn over time. You know, right. Trish at the time was 1 year out of university. Very young engineer. Very young engineer who probably thought they knew it all because, let's face it, I'm one of them. Most engineers, we come out of university and we think we know it all. We very quickly discover we actually know nothing. We need to learn. And you get a little bit of humility along the way and discover that other people know a lot more than you do and you need to listen to them. And that's part of the maturity process, I think. So, yeah, Trish today would do things very differently.
I was just thinking about the fail-safe on that ball joint. I mean, we put in, stops for example, my ATM, I can no longer leave my card in the ATM because I have to take the card out before I take the cash out. And they did a study, why are all these people leaving their cards in the ATMs? Because they take their cash and run. Well, if you have to take your card first, you no longer leave it in because you want your cash. So, those types of fail-safes, you wonder if those ball joints are still like that, and is that still a problem?
Yeah, I don't know because I haven't designed pipelines for a while, but you do kind of, the thought did occur to me even at the time of, so why is there a long and a short side? Why does it have two different lengths? Why does it need two different lengths? There's no real design reason for it that I'm aware of. And so that is part of the issue of, well, why on earth do you have that designed in? Because it is a potential for the human to get it wrong. I mean, the ATM example you use, it's a classic human factors example. I use that one a lot, actually. It really sums up human factors. If you make it easy for the human to get it right, chances are they're going to get it right. If you make it easy for them to get it wrong, chances are they're going to get it wrong. So if we can make things in our process industries easier to get right in the way we design them, then we will have less incidents because it's easier to stumble into the right way than the wrong way. So that's something that we do need to really be aware of. I don't know whether ball valves still do have that situation. I'd like to think that perhaps don't, but I don't know. There's a range of other things, for example, in an aviation fueling system that is very much all around the human, trying to make it as easy for the human as possible so that they do actually get it right. So even down to the precise location of where you put the fuel hydrant pit on the ground to make it as easy as possible for the refueler so the hose is not extended, because if the hose is extended, all of a sudden you've got an exposed hose on a tarmac that another vehicle can run into, and if they run into it, you will rupture the hose, you will have a leak. They have dead man switches, so the refueler actually has to hold a trigger for the entire refueling operation, or the pump stops. The fuel just doesn't flow if he doesn't hold the trigger. So if he is incapacitated in some way, the fuel stops. Those sorts of things. So there's a lot of different things that are built into the system. But the challenge with process safety as well is you need to make sure you don't get so sophisticated in your system that you introduce potential failure modes, or you introduce systems that require so much more additional maintenance on them that in the end it's going to be forgotten and missed. You actually need, in engineering, sometimes you hear people talk about the elegant solution. The elegant solution is often the simplest, not the most sophisticated. You can get very sophisticated and put all sorts of control systems and things in place in process safety, but you're potentially setting yourself up for failure. The simpler the process, whilst doing what it needs to do from a safety perspective, is going to be the elegant solution. The bells and whistles, they might be nice, but you probably want to be very careful about whether you pick all of them, because you will then have the potential for a design-related process safety incident or a human factors operational process safety incident to sneak in at that point.
So essentially, are you saying that some of these fail-safes will make the operators not lazy, but not understand the ramifications?
So it's not, fail-safes are one thing to be considered, but you need to make sure, there's no excuse or reason to not make sure the operators understand the process, because if something goes wrong, they need to be able to respond. They need to understand. So a completely different example here is a pilot learns to fly on instruments. But before they ever learn to fly on instruments, they actually learn to fly visually, and they learn to navigate visually, and they learn fundamentally the physics of flight, even though the plane does it all for them. But they have to learn those fundamentals in case the plane doesn't do it properly. In case something goes wrong, they have to be able to respond to it. So you've got to understand the fundamentals of what you're doing. You've got to understand the fundamentals of your process. You can then rely on your system to do it, but you've got to be able to understand enough to be able to intervene if it goes wrong. So I don't think it makes people lazy in what they do. I don't think it does that at all. I think one of the challenges is we can slip into a comfort mode that says, well, I know that the system will take care of that for me. My car at the moment has it's got that wonderful adaptive cruise control thing. So the car will slow down and speed up relative to other cars around it. Lovely. You've got to be conscious that you don't get lazy with it, though. Because sometimes it just doesn't detect that car in front of you. And so you're approaching a red light and there's a car in front of you and it's stopped and you're still going at 40, 50 miles an hour, and you think, oh, I'm getting a bit close now. I need to intervene. And I intervene and I take control back of the car to make sure, because for some reason, that particular instance, it just hasn't detected that vehicle maybe soon enough, or as soon as I would feel comfortable with, potentially as well. So you need to have the understanding to be able to intervene in it. There are certain fail-safes that should be installed. We should not be relying on operators to have to intervene in routine operations to prevent a major incident occurring. If a simple human making a mistake is going to result in a catastrophic incident, there's something seriously wrong with the resilience of your system, and you need to go back and rethink its design. Because if all that's preventing the major incident is an operator getting it right 100% of the time, you're setting yourself up for failure. So you've got to make sure you get the right fail-safes in, but, simply adding fail-safe device on top of fail-safe device on top of fail-safe device, adding extra ones actually doesn't necessarily make you safer. In fact, if you do some of the calculations behind it, you might find it makes you less safe at times as well. because it introduces common mode failure. Depending on the reliability of the device, it could introduce other failure issues for you as well. So when you actually do the calculations on frequency of failure, you might find it's gone the other way, which is not intuitive, but it can actually happen.
Getting back to your keeping it simple and eloquent. Well, I want to circle back. You had mentioned that your one job was the shipping operations, one of your most fun jobs. So why was it fun? You got to play with big ships, which was always fun. It was interesting to meet different people from all over the world. That was just a fascinating part of it. You know, the ship turns up and all of a sudden you've got to meet the new chief officer, you meet the captain, you go through all the paperwork, you do all that, and then you actually start what, at its most basic point, is a really simple operation. You're literally just basically connecting a hose or a pipeline of some sorts to a ship. They're turning on their pumps, and they're pumping it into wherever you're directing it. And it was an interesting position to be in terms of controlling where things went. So you were really sort of the master of your own destiny and what you put where. And, you know, the refinery needed it in certain places. They wanted their crude blended in certain ways. You would often have to negotiate with the ship on what they could give you, what rates they could give you, what tanks they could give you first, those sorts of things. And it was interesting to work with people from all over the world because you never really knew who was going to turn up on the ship. I made some friends that was fantastic, some of the people I met on ships. I had one instance where I was lucky enough to actually be able to board one of the ships when the pilot boarded it to bring it into Port Phillip Bay. So that was really interesting to watch the navigation through Port Phillip Bay, the heads, and then up the bay, and then the actual mooring of the ship as well. So, you know, just sometimes you got to do fun stuff. When there wasn't a ship in and I was at work, I was looking after the oil spill response equipment, which included a boat. So, you know, if it was a lovely day, then you'd go out for a boat ride, just because you had to run the engine in the boat and you had to make sure that everything worked, and so we'd go for a boat ride. You know, you'd have some fun in the job as well. I did it for about 18 months. It was hard work. It was tough, but you know, it was great fun. To play with some of the equipment that I got to use, to do some of the work that we did, to meet the different people. You know, big ships. I was a mechanical engineer. I don't know if you've ever seen the engine of a big ship. I have, yeah.
Big ship engines are really impressive.
Mm-hmm.
And my father, many years ago, was actually the general manager of a government facility called Engine Works, where they used to build big ship engines. So as a little kid, I used to go and see big ship engines being built, and then I got to go and see big ship engines in real life in ships. So that was a nice little tie-in for me.
Right, nice nod to your younger you.
Yeah.
Well, we've heard you said that you're not a fan of operations management. That's not a job you want. What would be your ultimate job if you could do a 180?
Oh, I have to say, I actually think I'm probably in my ultimate job. I think I'm one of these people in the world that has found their way into the job that they absolutely love. I get to meet different people from all over the world. I get to talk about something I'm passionate about. I get the headspace to be able to think about things, to be able to think about the next advances in process safety, to think about how we could improve things. When you're in a business, you sometimes don't get the headspace to do that because you're actually busy thinking about the day-to-day operation of the business. I don't have that challenge. So I'm able to focus my time on what do I think will be the next leading trend in process safety. And that's a really fortunate place to be in. But I'm also in the really fortunate situation that I get to visit with and see so many different companies. And so I get to see fantastic things happening all over the world in all sorts of different industries. and take some of those learnings and share them with others so that everybody can start to implement some of those little improvements, those little incremental things to get a little bit better in what we do. And so I actually don't think I would do another role if I had the choice at the moment. I really love what I do. We joke, if you won lotto, what would you do? I'd probably still do this job, to be honest, because I really enjoy it. I enjoy the research part of it. I enjoy the going to conferences and speaking part of it and meeting people and engaging with people. I enjoy working with different companies. I enjoy going on site visits to see them, to see how they do things. Yeah, so I think I'm pretty happy with this one, actually.
Well, it sounds like it. And you brought it up, so I'm going to ask, what is the next trend in process safety? What do you think?
Ooh.
What do you see?
You always give me a tough, controversial question, don't you? The next trend. I think it's not necessarily a new trend, but I think it's one that we still need to do a lot more work on, and that is human factors. I think the big issue is we need to create better learning systems for people, so we need to understand the human factors element of how people learn, so we can learn from incidents, because we still don't. We don't learn from incidents very well at all. But we also need to get better at our design, get better at our management of change, so that we can, when we do a management of change, we actually improve the system, not just do the change. One of the problems in management of change is we spend a lot of time doing the change, not so much time actually improving the system while we're there. So sometimes we end up with, what do they say, a camel is a horse designed by a committee? Sometimes we end up with camels. Maybe we needed to just fix it in the first place. So, I think there's a lot of space to improve more in human factors. So it's not a new trend, but it's certainly a big trend that needs to be really grasped by a lot of different people and embraced, so we can get better at it.
Well, we do have, and you are usually our subject matter expert on our safety webinars, but this next one that we have coming up is actually on preventing human error. Dr. Angela Summers is actually our presenter for that. But yeah, that's a fascinating topic. Just really something that I take great interest in as well. So definitely keeping our eye on that one. The last question that I have for you is, and I think I already know the answer to this, what do you think the next 5 or 10 years holds for you?
Well, I think I'll still be doing this probably for the next 5 or so years. Really don't think I'm going to head off anywhere different in that sort of time frame, to be honest. I'm still loving the job, so why would I move on at this point in time? But the other important thing for me is I'm still building with my team the safety centre, and succession planning is really important, but having that really strong foundation, so that 6.5 years ago I walked in the door to start this centre. We've come a long way in 6.5 years, from 6 original company members to 38 company members and 37 universities or regulators that are part of us now. So, significant growth in that time. But I'm not finished. I don't think I've got the centre to exactly where I want it to be. It needs to be more sustainable before I think about moving on from it. When the time does come, I do quite enjoy governance as well. So I currently sit on the board of one of Australia's safety regulators, and I quite enjoy the role of being on a board. So maybe I would be looking to more board positions into transition into the next phase of whatever my career is, possibly peppered with a little bit of consulting. To help people. There's a lot I've learnt over my career working in industry. There's a lot I've learnt over my career in this role. I think there's probably a lot I can share with companies to help them to move forward in process safety leadership in their organisation, improving their culture and process safety, improving their outcomes. So I guess that's probably where I see myself going, but I'm firmly planted here for the moment.
Well, you always prove to be a valuable resource, and we all know unfortunate events happen all over the world, and we will be here to discuss and learn from them. On behalf of Trish, I'm Tracy, and this is Process Safety with Trish and Tracy.
Stay safe.